Alright, time for another DraftPhysics.com video presentation in the category of tedious redundancy. Because they won't play my argument, okay? So another fake response video where, I've made these 5-minute videos, really short, okay, as concise as possible so they don't have an excuse to evade the argument, and they will not play the argument. And instead they do this jump cut bullshit and say, there, I've dealt with your argument, when of course they haven't dealt with it at all. First off, this is not Newton's mechanics. That's what they need to admit, that Isaac Newton didn't see it, he didn't believe in it, he opposed it. So understand, the guy who invented calculus didn't think it was good math, he didn't think it was rational, he didn't see any point in it, he didn't see any purpose in it. Alright, so just to emphasize a couple of points before I play this stupid video full of gibberish once again. This is not complicated. It was 9.8 meters per 1 second. Okay, one second. That's how much you get from gravity. Now, it doesn't matter how you want to draw that. You want to do 9.8 meters per second in this form, or you want to do 9.8, okay, and recognize that it's seconds down here, just 1 second, okay, per 1 second, meters per 1 second. There's no reason to put this under 1 second again, okay? And clearly, if you did it under 1 second, okay, it's harmless. You can't 1 times 1 times 1 times 1. If I want to put seconds and seconds and seconds and seconds, and it's all 1, 1, 1, 1. It's 9.8 meters per 1 second. If you go up half a second, then it's 4.9. Now you go a quarter of a second, okay, then it's 2.45. Okay, you go 5 seconds, then it's almost 50. So why are you playing this game, okay? It's 1 second. You have to go a full second to get 9.8. You don't go a full second in the gravity, you don't get 9.8. You go more than 1 second, you get more than 9.8. Okay, there's no 9.8 per seconds or hours or weeks. It's a very specific ratio. Deal with that argument. And it works perfectly in the sense that everything that's predicted by it is the outcome. You're 2 seconds in the gravity, then you're going to be going 19.6 meters per second. That's how fast you're going to be traveling. You're going to weigh twice as much. You're going to be in the gravity twice as long. All of those twos will be sitting there looking you right in the face. That's the reality. Ugh, this is just so annoying. So this is what he does to that argument.
Okay, this is going to be another response video to DraftScience about acceleration once again.
Yeah, and it has nothing to do with anything I'm saying. Yeah, clearly.
I'm going to play from here.
And then he says 9.8 meters per second squared is acceleration, because that's what we said. That somehow the rate.
So it's not what Newton said, clearly. It's not even what Leibniz said, okay? Leibniz just said mv squared, frankly. He didn't deal with any of this acceleration nonsense because he knew that, so it doesn't matter. It's the net velocity that you acquire in a real amount of time. It's not any ambiguous thing. You can't break the ratio.
The rate of acceleration is somehow something different, okay, than a rate of velocity. When no, it's just a change in velocity. So yes, it's the same.
Nobody says 60 miles per hour per hour. Nobody puts 60 miles per hour over another hour under a 1 or over a 1. None of this math is ever applied to any other circumstance in the universe except this one, to contrive this nonsense. This is not rational math. It won't get you right answers in any other circumstance. It doesn't get right answers in this one either. Jesus.
Same exact thing. You have a rate of changing your velocity, and it's the same as the rate of what's your velocity. So you can say you're going to go
Rates only work with standard units. It's 1 second. You have to use the same unit throughout the math. You can't change the unit.
60 miles an hour, but I'm going to decelerate at a rate of 4 miles an hour.
Okay.
That's what you could say, and it would make perfectly good sense.
Okay, so that would make perfectly good sense. You're traveling in a car, you're going 60 miles per hour, and you decelerate at a rate of 4 miles an hour.
Yes, 4 miles in 1 hour. It takes 1 hour for you to decelerate 4 miles off your velocity. So you remove 4 miles of velocity, 4 miles per hour, in 1 hour. Not a half hour, not a quarter hour, not an hour squared, not any other kind of unit of time. In that specific amount of time, you do that specific amount of change to your velocity. It isn't anything every millionth of a second. You can dice it and slice it all you want. You want to make it 9.8 meters per, you want to find the ratio that's correct for a millionth of a second. Well, yeah, then this number is going to be 0.0009.8 in a millionth of a second.
Now, in the same way, if we pick the gravitational acceleration, your initial velocity is 0 meters per second, and you're going to accelerate at a rate of 9.8 meters per second.
In a full second. 1 whole second. Not a millionth of a second, not a half a second, not a quarter of a second. You have to go 1 full second in the force, or you're not going to get 9.8. You go less than a second, you're not going to have 9.8. You go more than a second, you're going to have more than 9.8. So again, this is just such canardery, this lying you're doing about this simple fact that you have to do it in a consistent unit. If you change the amount of time, you have to change the 9.8. The 9.8 isn't consistent over any unit of time. It's consistent over 1 unit of time. Damn.
Now, what does that mean? You say that's acceleration, okay?
I say it's clearly a net acceleration in a unit of time. It's telling you what your total velocity is going to be at a unit of time, period.
Are you gaining? You say, so 0 meters per second, and then you accelerate at a rate of 9.8 meters per second.
Per 1 second. So again, you keep leaving out the 1 second. 1 second. If you change how much time, you have to change the 9.8. Damn.
9.8 meters per second. What does that imply? You're going 9.8 meters for every 1 second. You are
for every 1 second. There you go. That's right. So after 1 second, you've acquired 9.8 meters of velocity. Yes. Your velocity is now 9.8 meters per second.
gaining 9.8 meters every second. That's the only information you're giving me.
And that's all you need, and that's you get every single answer correct. You're going twice the velocity after 2 seconds. You're going to be going twice 9.8, and that's exactly how it comes out.
And you call that acceleration. That's only a linear increase of your distance.
So whatever that means, it has nothing to do with your linear increase in your distance. We're not measuring how far you travel, we're measuring the rate at which you accelerate. And obviously the amount you travel is going to be 4.9. So that's already a known fact. So the rate of 9.8 only gets you 4.9 meters of distance in 1 second. But it's perfectly understandable because this is a rate of acceleration. Your velocity is increasing until its maximum velocity of 9.8.
It's not a linear increase of your velocity.
Sure it is. So you can just say, let's do it in 1/10 of a second. How fast am I going after 1/10 of a second? Well, it's going to be 0.09.8. So, I mean, it's clearly you're going smaller increments and the distance is getting bigger and bigger and bigger by the same Galilean ratio, 1, 3, 5, 7.
Okay, 9.8 meters every second. That's what you're gaining.
1 second. That's right, every 1 second. So there's nothing else you can gain. You can't get more than that. You can't get less than that. You get 9.8 meters of velocity.
So it would be more correct to say you're gaining distance at a rate of 9.8 meters per second. Again,
I mean, wait, you just restate the same thing over and over again. Just say the 1, please. Just include the 1. 9.8 meters per second per 1 second. There.
meters per second itself, that implies constant velocity. You're only gaining.
There's no constant velocity. Your velocity is constantly increasing through the acceleration. It's a constant acceleration. So you didn't even get that part right. It's a constant acceleration and your velocity is constantly changing. But after 1 second, you'll gain 9.8 meters per second of extra velocity. So if it was put in 60 mile an hour kind of notation, you're going 60 miles an hour, you'll go 120 miles an hour after 2 seconds.
An amount of meters for every second, which means a linear increase of distance, so a change in distance, a linear change in distance, not a linear change of velocity.
So again, of course, it's a linear change in velocity through the entire acceleration. So more nonsense. It's a net amount of velocity that you're going to get. And again, we already know that the real distance, okay, the distance is only going to be 4.9.
However, if you mean that if your initial velocity is 0 meters per second, and if your initial velocity is 0 meters per second, and eventually you're going to have a velocity.
It's a final acceleration number, okay? It's not telling you how much you accelerated the first millisecond. It's not telling you how much you accelerated the second millisecond. That's not what it's telling you. You want the average acceleration, well then just, yeah, you can figure out how far it went and then do an average. But it's telling you what the ultimate end result will be after 1 second, which is you will gain 9.8 meters per second of velocity.
You're going to increase, you're going to accelerate towards a velocity of 9.8 meters per second. Okay, you're going to have to tell me how long it took me to go.
1 second, fuckhead. Shit. It's amazing. I don't have to tell you anything. It's already telling you. 1 second gets you 9.8. Some other number of seconds gets you some other number.
From 0 to 9.8 meters per second.
1 second.
If it took only 1 second.
Yes, exactly. That's what it took. Exactly 1 second. That's what Newton said. That's what it equals. That's what the end result is. Yes, that's exactly how it works. 1 second.
Okay, then that means that I have gained 9.8 meters per second in 1 second.
Exactly. That's what you've done. That's all you've done. That's right. So if you're in the gravity for 2 seconds, you're going 19.6. Exactly the way it comes out, no problems. You're the ones inventing some notion that somehow that means you have twice the energy now.
Meters per second per 1 second. Okay, that would be the.
It's not meters per second per 1 second. So again, what is that jargon? It's meters per second right here. That's all. There's just one. 9.8 meters per 1 second. The end. There isn't anything else. There's nothing else to add. It already says everything that needs to be said. Nobody says 60 miles per hour per 1 hour per 1 hour. No one does that. It's not rational. It's nonsense. And just so keep doing it. Fine. Okay. We'll get how desperate you are. How desperate you are to defend absolute nonsense that you don't apply to any other circumstance in the universe. No other place do you apply this nonsense per second silliness.
Change my velocity over time. And that's acceleration. My velocity is changing in time. What is your unit of velocity? Meters per second. What is the unit of time? Seconds. My meters per second is changing every second.
It doesn't matter. It's telling you the net answer. The net answer is 9.8 meters per second. In the sense of 1 second gets you 9.8. That's the ratio you have to deal with. That's the fact. You can't break that fact.
Okay, now let's go a little bit further. further when you start drawing.
Yeah. Let's just break the video into little tiny pieces. Okay, I play your fucking lousy, cruddy, shitty, fucking annoying goddamn videos, and you can't give me the same fucking courtesy. You fucking piece of shit.
On the board, or writing on the board.
Then it isn't. Say 9.8 over 1 second. That's the rate. Okay, that's the.
Yeah, let's see him do something with that. Explain how that's not exactly what Newton said. That's the equation you have to deal with. I mean, Newton said 16 feet, of course, but whatever.
Proven fact. Okay.
Yes, I don't disagree with that.
Okay, then you're done. There's nothing else to say. That's all there is. There's no other math to do to this. There's no other way to, no need to break it any further. It's 9.8. I didn't put the meters here, but it's meters per 1 second. The end. You've described the mathematical relationship. There's nothing else to do to this. There's no need to break this simple ratio of 9.8 to 1.
You start after once you start your initial velocity is 0 meters per second. After 1 second, your velocity is 9.8 meters per second. After 2 seconds, it's 19.6, etc. I don't disagree with that.
Well, there's no point then. There's no point because there's absolutely no way to contrive any other fucking bullshit. What's the other bullshit then? What other information do you need? You've been given the velocity. It's 19.6. You're saying 19.6, the velocity means somehow I square that number. I square the 9.8 after 1 second. You're just making up this fake notion that there's all this extra energy. From where? Where do you derive it from? There's nothing here in this ratio that says there's any squared function. There's nothing in the falling that shows you any squared function. It falls in 2 seconds. It's 2 units of 9.8. I can do 9.8 times 2. The end. I'm done. I've got my mass and my velocity. What the fuck does this have to do with kinetic energy? Absolutely nothing. There's no reason for me to think I put this under another fraction.
Proven this one.
Sure.
We've dropped things. Galileo did it.
Yes.
We dropped them. We measured it. That's the rate that the stuff falls.
Yes.
Okay, so we know that it gets that velocity. Now we know that as you drop something.
Okay, so you drop something. Your initial velocity is 0 meters per second.
It has to increase its velocity, but that's
Yes.
the final what you're going to get after 1 second. So after 1 second, it'll be traveling 9.8. It will have.
After 1 second, you will be traveling 9.8. 9.8 what?
I mean 9.8 meters per second. It's a velocity. There's no other way to denote a velocity than to say it has to be in units of distance over time. So you're just saying, okay, it's 9.8 meters per 1 second. That's the unit. I mean, what the fuck? How can you break something so simple?
Why don't you say the unit? You start with 0 meters per second. After 1 second, you are traveling 9.8 meters per second.
Per 1 second. Per 1. Why do you keep evading the 1? Why do you keep not including the 1? It's not per seconds. It's per 1 second that you do 9.8. 1 second.
Which means after 1 second, I have gained 9.8 meters per second. In 1 second. So
yes, so just play the video, would you please?
9.8 meters is what I have gained per second in 1 second. And so the next second, I'm going to gain another 9.8 meters per second. And the next second, I'm going to gain another 9.8 meters per second. For every second, I am gaining 9.8 meters per second. In other words, 9.8 meters per second for every second. Meters?
Yeah, duh. For every 1 second. For every 1 full second.
Per second. Per second. You have to tell me if you have initial velocity,
Again, nobody says 60 miles per hour. Okay, nobody ever said it in the history of mankind except me as mocking rhetoric, because nobody says it. How fast were you? Oh, well, it's going 60 miles per hour. Nobody says it. Okay, nonsense. It's just baby talk. It's just a contrived pile of nonsense babble. Nobody says it. Of course you can go for 10 seconds in gravity, or you go for a half second in gravity. Yes, you can go a variable amount of time. So what? You're going to go an actual amount, and the actual amount will depend on how many seconds, exactly how many seconds you're falling in the gravity. If it's 2 seconds, well, then it's just 2 units of gravity. It's not 4 units of gravity.
So the change velocity means I have initial velocity, and then at this point I have another velocity, okay, 0 meters per second, and then eventually I have 10 meters per second. How long did it took?
1 second.
To go from this velocity to this velocity. You have to add time, another time unit.
Why? It's right here, 1 second. The answer is 1 second. That's what you did. You did 1 second. So if I change this to a half a second, then I change this number. If I change it to 2 seconds, then I change this number. There's nothing. It's all right here. Meters per second. Period. There's nothing else. Meters per second. There's no per second seconds. Seconds. And even if there was, it can't matter because it's always 1 second.
Another unit of time. If it's 1 second, then it means 0 meters per second here. It took me 1 second to go from 0 meters per second to 10 meters per second. So I have gained 10 meters per second in 1 second.
Travel.
Yeah. So where did he say anything there? Anything different?
The distance, okay, of 4.9.
Because if we are only allowed to use meters per second, then that only applies. Meters per second itself is constant velocity.
So again, it's not a constant velocity, so no one's talking about a constant velocity. Obviously, the velocity is changing through the entire process of the object falling. The velocity is increasing with every single millisecond. So it's not a constant velocity, it's a constant acceleration, and the constant rate is 9.8 meters per 1 second. So he has that part backwards.
A change in linear distance, not change in linear velocity. Now, okay, about the distance, the dropping distance, etc. That's, I agree with all that. It's not a problem.
Yeah, well, what do you mean? You just said distance, and the distance is 4.9. Well, that's obviously not how we're measuring the force. We're not measuring the force based on the 4.9. We're not using 4.9 meters per meter, or 4.9 meters per second in terms of we're going to measure it by distance. So that's not what we're doing. We're saying what's its velocity. Clearly, this equation is used to detect its velocity, not its distance.
All right, so let's now try to explain again how they derive meters per second squared. Now, first of all, per second.
So that's it. That's all he does. So I show exactly what happens, which is in the second you go 3 units of distance. So you only want 1 unit of distance in the first second. You're going 3 units of distance in the second because of your accrued velocity change, because you have increased your velocity. And so you're traveling through the gravity much more distance, but you're only in the gravity for the 1 second.
Squared doesn't mean the squared thing is not the exact meaning as when you square numbers.
So again, more baby talk. You're drawing it as a squared number. You're showing it as a squared number. So they say per second. That is 60 miles per hour means it's 60 miles per hour squared. So you're going 60 miles per hour squared, whatever the fuck that means. Per 1 hour squared, well, 1 hour squared doesn't mean anything. Just in this case, 9.8 meters per second squared doesn't mean anything because it's 1 second.
It has a different meaning. Squaring units is not the same as squaring numbers. Again, you don't have to square. If it's 5 meters per 1 second squared, you don't, or if it's 5 meters per second squared, That doesn't mean that it's 5 meters per 1 second squared. You don't have
Oh, yeah, it means you're putting seconds in the equation twice. So don't tell me it doesn't mean that. That's exactly what you're doing. That's what the square means. There's seconds times seconds. Why would I multiply the same second times the same second again? Why would I do that? There's absolutely no reason to multiply the seconds times the seconds.
to square any number. It's just a notation thing.
So again, this lie that this isn't just a notation thing. It's a notation that you write as a square, which means it's the number times the number. There's no reason to multiply the seconds times the seconds. You already have meters per second. There's no reason to add another second. And there's certainly no reason to do it if you understand that the ratio has to change if you're going to change that seconds to some other number besides a 1.
So if we have meters per second, I'm going to write that differently. Meters per second, it is written as a fraction, like that.
Right, and so why? Okay, it could be written as a multiplication, meters times seconds. That's how they actually do newtons, right? It's meters seconds, so it's meters times seconds. Because it wouldn't make any difference, because the seconds is just a 1, for fuck's sake.
Meters per second per over a second.
So there he goes. There we go. Now we have seconds twice for no reason. Absolutely no reason to change 9. This could be written 9.8 meters over a second, or it could be written 9.8 meter seconds. Could be written either way. There's absolutely no reason to write it this way. There's absolutely no reason to put another line here and put another S in here. No reason whatsoever. So you just contrived nonsense. You just built a little piece of nonsense to screw up something that was perfectly sensible. We already have meters per second. Why would we add this extra seconds? Oh, because they have to create fake energy. So this is how you create fake energy.
Okay. That's how it's written. It's written. You can write it out like this, meters per second.
Why would I do that? Again, I've never even seen that notation, frankly. Can you put a third S, a fourth S, a fifth S? I mean, how many S's can you add? You can just add them arbitrarily, as many as I want?
They just figured in physics, well, we can write it even shorter.
Yeah, why can't I just say meters per second, 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 per second? And I can really make big numbers.
Order. We don't have to write meters per second. We can write it differently. And so what I do is you can.
All right, well, just show me where they wrote it like this. Meters per second per second. Show me where they write this.
Write it as a fraction. Now, of course, you cannot divide meters by seconds. But this is just.
You're just establishing that it's units per second. So again, it would be irrational to attempt to actually multiply or divide an actual unit into some other kind of unit. Okay, a kilogram into a what's another unit? A heat unit. A Kelvin.
Just about units. You do not. The way you do this is not the way you do this with numbers.
So so the way you do this is to break all logic. So again, he's written it. It doesn't make any sense. I shouldn't have to go any further. I shouldn't have to explain any further that you've just arbitrarily added another second for no good reason.
Okay, that's a different meaning. But they do it in the same way. But it's just for the sake of notation. It has nothing to do with how you.
It's for the sake of contriving a fake entity that exists that doesn't exist. This is a ghost. This is a fake. This is a fraud. This is a phony. This isn't anything real that happens. You can't draw where this happens. So show me when an object is falling. Draw an object falling. Draw it on the board. And then show where this extra second happened. Show on the board where you've put this extra second in. This extra unit of time.
Numbers, really. It's just for the sake of notation. You want to create the shortest possible.
So this is shorter. Okay. meters per second is shorter. Yeah, short is.
Way of notating acceleration. No big deal, really.
Oh, I mean, just amazing. It's an entire source of contrived crap, and he says no big deal, really. I mean, I mean, this video is just such a piece of shit. This is how you respond. Okay, you're slandering Newton, saying Newton's an idiot because he didn't see your extra free kinetic energy crap. He didn't see it in the evidence. He didn't see it in the world. Okay, and you're insulting him, frankly, and saying he's an imbecile. And Galileo was an imbecile for not seeing this magical energy. And Descartes was an asshole for not seeing this magical energy because they didn't think it was rational to put seconds under seconds.
So you write it out as a fraction meters per second over seconds, and then...
What a pile of crap. Again, he has it sitting here on the board, and what does it mean? Where does it come from? Where is its origin? Why did you do that? So if I had 60 miles per hour, I should put another hour under it for some reason. It's 60 miles per hour per another hour for some dopey reason.
You want to turn this one also into a fraction?
Yeah, so make it even worse. We already know it's a 1. It's 1 second. 1 meter, meters per 1 second. Per, again, you can't say seconds. Okay, this would be a lie to say this is any number of seconds.
The way to do that is just to put a 1 over here. Seconds over 1 is the same as just seconds. Seconds divided by 1 is just...
So this doesn't matter. This doesn't change anything except now you're going to invert and multiply and say seconds squared. And again, it's 1 second. So we put the actual mass number in here. We put the actual number of seconds. So let's put the actual meters, put the actual seconds, put the actual numbers in here, and know what you're going to end up with? 9.8 divided by 1 divided by 1.
Seconds. So now you have fraction divided by a fraction over fraction. And in algebra, the way to calculate this is to take the reciprocal. So you take meters per second, and then you flip these upside down, and then you multiply it with this. So now we have meters per second times. You take this, but flip it upside down. Like that. And then it becomes...
So if we have 9.8, right? 9.8 times 1, 1 times 1, 9.8 over 1 is 9.8.
Becomes meters, and then you have to just multiply meters with 1 and multiply seconds with seconds. And that would be meters over second squared. This is just another way of notating.
Oh, yeah, whatever. So fine. This is what they stand on. This is their integrity showing. So he says this is nothing. I'm just putting this extra seconds here because it's just fun. It doesn't mean anything. It doesn't mean, oh yeah, it's squared function. It doesn't mean any of that. And then he shows you exactly how he's going to put a squared function into the equation for no good reason. So now it's 9.8 meters per 1 second squared. Okay, fine. That's still harmless as long as you recognize the unit is 1 second. 1. 1, 1, 1. So the actual units are missing here. It's 9.8 meters per 1 second.
Creating meters per second. It's a shortcut. It's just the shortest way possible to notate meters per second per second.
It's just a cheat cut, clearly. Contrived crap.
Or to notate acceleration. It's just a notation thing. That doesn't mean that when you add numbers in front of these units, so you have now this unit, you have meters, or
So they changed Newton's formula into 9.8 meters over seconds squared. Whatever the seconds are, right? It's supposed to be over 1 second. So now it's ambiguous how many seconds it is.
per second squared. And now you're going to place a numerical value in front of it, let's say 5 meters per second squared. Well,
So what happened to the first ratio? It was 9.8 meters. Now the ratio is gone entirely. There's no ratio here. It's just squaring seconds, whatever seconds are. So how could you possibly solve this if you're just going to arbitrarily say 5 meters? Well, the 5 meters has to be counted as times the rate, the real rate, which is 9.8. Where's the 9.8? You've completely lost it.
there's an imaginary 1 over here. For every 1 second, you're gaining 5 meters per second.
What are you making up?
The mistake being made here is that, or the confusion is that you have to square this number. Well, no, it's separate. The numerical values are separate from the units. It's only about the unit. The squared seconds is only about the unit.
Well, it doesn't matter. The unit is going to eventually be, the square is eventually going to be applied to the number of those units. So what's the point? You're going to end up squaring the 2 seconds. I put 2 seconds. I do it for 2 seconds. You're going to say it's 2 seconds squared. Well, no, it's only 2 seconds. It's only in the gravity 2 seconds. It's not in the gravity 4 seconds. It's in the gravity 2 seconds. So you're going to change 2 seconds into 4 seconds. That's all you're going to do, liar.
In this case, you should not. So it's only, this is separate. You don't have to square the 1, or you don't have to square 5. You don't have to square anything. Seconds squared just means seconds per second.
It keeps saying it, seconds per second. It's not, you're not multiplying the seconds per second. You're multiplying it times a real specific number of seconds. The seconds you're multiplying the 1 times is a number of seconds. How many times did you do the 9.8? Did you do the 9.8 2 seconds, 4 seconds, 5 seconds? That's the number you multiply times 1. You don't square anything. It's 1 times 4 seconds. Well, then you know you're going, 50 miles, 50 meters per second. I mean, what a pile of absolute crap.
Squared has a different meaning than squaring a number. Okay, because second itself, of course, doesn't contain a numerical value. It's a unit.
Well, let's just say that in every single case, in every other mathematical circumstance, this number, this square does not mean you're squaring some vague unit thing. It means you're squaring the damn number in front of it. So again, more lies by these people, frankly. If I wrote 9.8 meters squared, okay, everybody would know I'm not squaring some vague unit. I'm squaring the 9.8.
But of course, you cannot square it as you would square numbers. So it means something different. In this case, it just means it's a different way of notating.
Okay, so it's just a lie. I mean, frankly, the notation has to be consistent. And every single time somebody sees that written, they're going to say, that's this 1 squared. Every single time. There's not going to be any mathematician who's going to see anything other than that if that's all you write. So bullshit. This is such a pile of bullshit. This one special case of gravity, well, this squared thing means we don't really square it until we come up with the number of seconds. Then when we have the number of seconds, we square that number. So instead of being 1 times a number of seconds, now we're going to change it into the number of seconds times the number of seconds.
Meters per second that you gain every second. meters per second. It's another way of notating. It's a shorter way of notation, they did this by using algebra. Is this 100% necessary?
Is this contrived? Is this just a distortion and a defect? Is this just absolute bullshit made up for the purpose of contriving some sort of linear logic to explain? Yes, that's all it is. It's just a rationalization, and it's clearly just a rationalization. It's a fake, phony, injected after the fact to create an illusion. And that's all this is. And you're pointing it out that this notation is complete bullshit. We never use it for any other purpose than this contrivance.
I would say no. It's exactly the same as meters per second for every second. That is necessary. Your change in velocity is...
It's exactly not the same. So in the real case, it's going to be a 1 second times the number of seconds. It's going to be, say he should have just said this is 9.8 meters to keep it consistent. 9.8 meters, okay, per 1 second times the number of seconds. So it would be 1 times 4 seconds, or 1 times 6 seconds, or something like that. That would be clearly what you're going to do. And instead, they've contrived it. They're going to cross out this 1, and they're just going to say 5 seconds times 5 seconds. 4 seconds times 4 seconds. So instead of multiplying the unit times the other unit, okay, they're going to cross out the 1 unit and just say it's the unit squared, and then square the number of seconds. So instead of just going, 5, you're going to go 25. And that's how they create their kinetic energy fable.
Is your velocity, meters per second, that is being changed in a certain amount of time, and we pick seconds as that unit of time. So your meters per second is changing every second. That is necessary. And a meters per second squared.
Oh, lie.
But
There's nothing necessary. It's 9.8 meters in 1 second. It's not anything else. It doesn't matter how often your velocity or your acceleration changes. It doesn't make any difference. The net result is 9.8 meters in 1 second, period. That's the consistent fact. And if you travel for 2 seconds, then you only got 2 units of 9.8. You didn't get 4 units of 9.8. You only got 2.
A shorter notation.
Lie.
Of course, this will change nothing about this debate. Nothing will change, so this is a perfect waste of my time and your time.
Yeah, well, you couldn't even give me the courtesy of playing my real video, okay? Playing the whole argument where I explain it's 2 times the time, it's 2 times the velocity, it's 2 times the weight, and you've contrived a completely fake 4. All right? And we know the 4 is fake because we know that it's not 9.8 meters per meter. It's not 9.8 meters per unit of 4.9 meters. It's not 9.8 meters per anything else than 1 second. And it's only in the gravity for 2 seconds, so it can only collect 2 units of force. It collects the force in units of seconds. 1 second at a time, 2 units of time, 2 units of force.
But anyway, thanks for watching, and...
Why don't you explain how Descartes, Galileo, and Newton were ignorant morons because they didn't see your magical per second trick? Why don't you explain to them, explain to me, explain to Newton, explain to Descartes, explain where they made their huge giant mistake in not recognizing this kinetic energy bullshit? Why don't you show how the experiments show they were wrong, how their whole understanding was completely upside down and backwards because they didn't understand that it took 25 times the force to go 5 times faster? Why don't you explain it to them? Explain how could you make that mistake, you morons? Didn't you see how obvious it was that, to go twice as fast, you had to feed the horse 4 times as much? Fucker.
see you in my next experiment video.
Which will be a piece of shit, like every other piece of shit video he does. Alright. God damn fucking weasels. So I won't do the... I mean, I won't draw it, but again, the point is why don't they do that? Why don't they just draw the look? Yeah, I will do it. And show us where this happens, this magical, where does the magical kinetic energy jump in? Where does the magical force come from, this extra amount of force? Where? In the description of a falling body. Where is it? All right, again, Galileo made the point. He described the point. He showed the point. All right, so it's this simple. Too much glare. Damn it. All right, I'll pause for a second. All right, should be better. All right, so it's 4 times the distance, it's twice the time. There's only 2 units of time. So this happens in 1 unit of time, you get this. The exact same thing happens here. So exactly the same acceleration. So I drop it from 1 unit of distance. This essentially does the same thing. I get 9.8 here. That's all it's going. 9.8. This one lands with 9.8. Okay. And then this whole distance here, clearly it only gains 1 unit of the force. This is a unit of force, 9.8. You can detect when a unit of force has gone in because it has a signature of a 9.8 increase in your velocity. Well, I only get 19.6 here. So I clearly have only gained 1 more unit of 9.8. So I obviously did this whole distance, all right, and all I gained was 9.8. That's what a unit of force equals, is 9.8. That's what Newton said, 9.8 per 1 second. Okay, that's all you can get. That's all I can get. It's 1 second here, it's 1 second here. This is 1 second, this is 1 second. All I can get is 2 units of force. So why don't you show me, where in here did your extra energy pop in? Where did the 2 units turn into 4 units? Show me where it could be possible that I could get 9.8 here and somehow I gained 3 times the energy here, okay, even though my velocity only increased by 9.8. But I got 3 units of force. I got 1 unit of force here, and I got 3 units of force here, okay, but I only got 9.8 more in velocity. The force is identified by this. I only got 1 unit of force. It's completely consistent, but yeah, it's only 2 units of time. So I only felt in 2 units of time in the force. So why don't you show me in this diagram where I got these extra amounts of force, where I collected them? Because it's obviously not 9.8 meter per some unit of distance. It's per a unit of time. Ugh, fuck. God, I hate this planet. Frickin' morons.